All right, if you're a data scientist or a technical auditor, you already know that understanding the how behind a model is every bit as important as the what. In this explainer, we're going to break down the core types of machine learning to give you a solid framework for both building and auditing these incredibly complex systems.
We throw the term machine learning around all the time, but it's not just one single thing. The really interesting question isn't just what it is, but how does a machine fundamentally learn from data in the first place?
Well, it really all comes down to three main approaches. And look, grasping the difference between them isn't just nice to have, it's absolutely critical for building robust systems and, just as importantly, for auditing them effectively. So, let's jump into the first one.
Okay, so I want you to think of our first method as learning with a teacher. A very, very patient teacher who gives you an answer key for every single question. This is the world of supervised learning.
The key thing to get here is that supervised learning runs on labeled data. For every single piece of input data we show the model, we also show it the correct output. The whole goal is for the model to figure out the relationship, the hidden rule that connects those inputs to their outputs, so it can then make smart predictions on new data it's never seen before.
So, you can see here how different tools get used for different jobs. Linear regression, that's your go-to when you're trying to predict a continuous number, like a home price. But when you need to sort things into buckets, is this a yes or a no, a this or that, we turn to things like logistic regression. Let's dig into that one.
Think about your email inbox. That spam filter? It's a classic example of logistic regression in action. The model gets trained on a massive data set of emails, where every single one has already been labeled spam or not spam. It learns to spot the patterns, so when a brand new email comes in, it can calculate the probability that it's junk. It's a simple, binary choice.
And this really hammers home the biggest difference, right? Supervised learning is all about having that answer key. It's a very directed, goal-oriented process. But what happens when you don't have an answer key? What if you're just given a giant pile of raw data?
Well, that brings us to our second big idea. This is where the machine is less of a student and more of a detective, sifting through all the evidence on its own to find clues and connections. This is unsupervised learning.
So with unsupervised learning, you're basically telling the model, here's a whole bunch of raw data. I'm not telling you what's important. You go figure it out. Its entire job is to explore that data and find the natural groups and hidden structures all by itself. It's about discovery, not prediction.
You've got a few key techniques here. Principal component analysis is fantastic for simplifying really complex data, but clustering, that's where the magic of finding hidden groups really happens. K-means, for example, is a super common way to group data points into a set number of clusters based on how similar they are.
Marketing is the perfect example. Imagine you have a huge database of customers, but you don't know who belongs with who. K-means can just dive in there, look at everything from purchase history to browsing habits, and automatically group them into distinct segments. The machine literally finds your target audiences for you.
Okay, let's switch gears completely for our third and final pillar. This is a whole different ballgame. We're not learning from a static data set at all anymore. We're talking about an agent learning by doing, by pure trial and error in a live environment. Welcome to reinforcement learning. The setup is kinda like this. You have an agent, that's our model, and it's plopped down into an environment. Its one and only job is to rack up as many points or rewards as it possibly can. It learns what to do by just experimenting and getting feedback. And this feedback loop is the absolute heart of reinforcement learning. The agent tries something. The environment immediately tells it if that was a good move or a bad move, with a reward or a penalty. The agent takes that feedback and updates its strategy. And it just does this over and over and over again, maybe millions of times, until it hones the perfect strategy.
Now, Q-learning is one of the foundational algorithms here. You can think of it like the agent is building its own personal cheat sheet, this thing called a Q-table. For every single situation it could possibly be in, it calculates a quality score, or Q value, for every single move it could make. It tells the agent the best possible action from any given state. Picture a robot trying to navigate a warehouse. Every time it makes a move that gets it closer to its destination, ding, it gets a little reward. But if it bumps into a shelf, bonk, it gets a penalty. Through Q-learning, it slowly but surely builds a perfect internal map of the most efficient route, all by just trying to get the highest score.
So, let's pull all this together. We've got our three pillars: supervised, unsupervised, and reinforcement. And for those of us actually building and auditing these systems, this isn't just theory. This gives us a really powerful and practical framework for asking the right questions.
This really boils it all down. If you're looking at a supervised model, you have to go straight to the source, the labels. Are they accurate? Are they biased? Because, garbage in, garbage out. For unsupervised models, it's all about that raw data. What hidden biases might be lurking in there that the model will just find and amplify? And with reinforcement learning, you have to put the reward function under a microscope. Is it really encouraging the behavior you want, or could it lead to some wild, unintended side effects?
At the end of the day, it's just not enough for a model to work. You have to be able to explain why it works. So the next time you're digging into a model, don't just ask what it does. Ask the most important question of all. How did it learn? Because that's where you'll find all the answers you need.